In 1940, American radar was a joke, but a single device, small enough to hold in your hand, would soon be trusted to save London from Hitler's vengeance weapons. When the V-1 buzz bombs first hit England, it seemed nothing could stop them. They were too fast, too small, until an American system, powered by a secret British invention, began hunting them from the sky. We all know radar won the war, but most don't know the story of the one component that turned our radar from a clumsy toy into the weapon that defeated the V-1. In 1940, American radar was a joke, but a single device, small enough to hold in your hand, would soon be trusted to save London from Hitler's vengeance weapons. This is the story of how that one piece of technology changed everything almost overnight. The device was called the cavity magnetron, and when American scientists first saw it, they were stunned into silence. It wasn't just an improvement, it was a quantum leap. You see, before this, radar was a clumsy giant. The British had their chain-home system, massive 300-foot towers that could spot German bombers coming. It worked, but it was brute force. The Americans? Our systems were even further behind, operating on wavelengths so long you could practically see them. Many of the stories we share here are about these forgotten turning points, and if you enjoy this kind of history, a simple click on that subscribe button lets us know we're on the right track. But the cavity magnetron changed the game. It was a British invention born of desperation during the Battle of Britain. It generated microwaves, centimeter-long waves. This was the breakthrough. Why? Because short waves meant small antennas, and small antennas meant radar could finally be small enough to fit on a ship, in an airplane, or in a mobile unit on the ground. This discovery was so vital, it was flown to America in secret, part of the Tizard Mission. It was perhaps the most valuable item to ever cross the Atlantic. But having the device and turning it into a weapon were two different things. The U.S. Army needed a system that could not only see the enemy, but aim the guns. This was the challenge given to the brilliant minds at the MIT Radiation Lab. And what they built was the SCR-584. It was a marvel. Unlike older radars where a man had to crank wheels to follow a blip, the SCR-584 did the work for you. It had a helical antenna that spun in a cone shape. If the return signal was weakest in the center of that cone, the radar knew it was off target. So it automatically corrected itself, locking onto the target with terrifying accuracy. But this new weapon almost came too late. By 1944, the Allies had invaded Normandy. Hitler, in a fit of rage, unleashed his new terror weapon, the V-1, the buzz bomb. These were not like bombers. They were small, pilotless jets flying 400 miles an hour. They were weapons of pure spite, aimed not at armies, but at the homes and morale of the British people. The existing defenses were useless. The big chain home towers couldn't track something that small and fast. The anti-aircraft guns? They were firing blind. In the first week, over 1,600 V-1s were launched, and only 17% were being shot down. London was bleeding, and the panic was real. The Allies were desperate. This is where the story turns. General Frederick Pyle, the man in charge of Britain's air defense, made a radical decision. He put all his faith in this new, unproven American radar, the SCR-584. He also paired it with another brand new invention, the proximity fuse. This was a tiny radio in the shell itself, which would detonate the shell when it got near the target. No direct hit was required. They rushed the SCR-584s to the English coast. The setup was revolutionary. The radar would lock onto a V-1. Its analog computers, a room full of gears and calculations, would instantly figure out the V-1's speed, altitude, and direction. It would then automatically transmit that data
directly to the gears of the 90mm anti-aircraft guns. The gunners didn't even have to aim. They just had to load the shells. Imagine being one of those gunners in the summer of '44. You hear that awful, sputtering sound of the V-1 engine in the dark. You just load the gun, and then you watch as the barrel swings on its own, tracking an enemy it can see but you can't. You fire, and seconds later, a flash in the sky. The buzzing stops. The results were staggering. In the first week of using this new system, the kill rate jumped from 17% to 24%. By the fourth week, it was 74%. On the last day of the main assault, 104 V-1s were spotted. 68 were shot down by the guns, 16 by fighters. Only 4 got through to London. The SCR-584, powered by the Magnetron, had saved the city. But the V-1 threat wasn't over. After the Allies broke out of Normandy, the Germans turned their sights on Antwerp, the vital port city in Belgium that was supplying the entire Allied advance. This time, the attack was even more brutal. It was the winter of '44, during the Battle of the Bulge. The V-1s rained down, and the U.S. Army had to defend the port or the war effort could stall. This was the SCR-584's finest hour. They called it the Antwerp-X defense. They set up a ring of these radar gun batteries. It was a complex, layered system, a true testament to American logistics and engineering. The Germans launched thousands of V-1s, but the SCR-584s, manned by American GIs, formed an iron shield. It's hard for us to picture just how advanced this was for 1944. This was the world's first truly automatic integrated air defense system. It was a computer, a radar, and a weapon, all talking to each other. We hear from many viewers who actually worked with this Cold War-era tech. If you have memories of these systems, please share them in the comments. Your knowledge is a living history, and we all benefit from it.
This system was so effective that it became the foundation for everything that followed. After the war, the SCR-584 technology was used to track weather balloons, which led to the first radar-based weather reports. It was used to guide missiles. And that automatic tracking, it became the basis for the missile tracking systems used in the Cold War, and even for tracking the Apollo missions to the moon. And it all came back to that one little device, the cavity magnetron. It's a powerful reminder that sometimes the biggest changes don't come from the biggest machines. They come from a single, brilliant idea, shared at the right time. The British had the idea. The Americans had the industrial power and the engineering genius at places like MIT and Bell Labs to make it a reality just when it was needed most. The V-1 was a terrifying weapon. It was the dawn of the missile age. But the SCR-584 was its match. It was the first point-and-click weapon. The moment that human error, the guesswork of aiming, was taken out of the loop. That's the moment the entire nature of warfare changed forever. It's easy to look back at World War II and see the massive armies, the tanks, the great battles. But we often forget the war of the engineers, the quiet battles fought in laboratories and on drafting boards. The scoffers at the start of the war were right about one thing. Early U.S. radar wasn't up to the job. What they couldn't predict was the speed of innovation. The cavity magnetron was the spark. The SCR-584 was the fire, and the V-1s were the fuel it burned on. It's a powerful story of how ingenuity, born from desperation and forged by cooperation, can create a shield that saves nations. Today, the principles of the SCR-584 are in so many things we take for granted. Your microwave oven, that's a direct descendant of the cavity magnetron. The air traffic control that guides your flight, its ancestor is the SCR-584. It's not just a museum piece, it's the DNA of our modern world. So, the next time you see footage of those old anti-aircraft guns, remember what was really happening. You're not just seeing men loading shells, you are seeing the birth of automated warfare, the first act in a play that continues to this very day. If this history is as important to you as it is to us, consider sharing this video with a friend who appreciates this kind of story. It's the best way to keep these memories alive. We cover the tech, the tactics, and the people who made history. If you'd like to see our next piece on the classified Bat Bomb, the first smart weapon, say yes in the comment box. Thank you for lending us your time and attention.